Lesson 2, different versions of blockchain. Blockchain technology has matured through different stages, often referred to as versions. These versions reflect how the technology's capabilities, use cases, and underlying mechanisms have expanded over time. Blockchain 1.0, the emergence of cryptocurrency. Overview: the first generation of blockchain is most famously associated with Bitcoin, launched in 2009. The focus here is on peer-to-peer digital currency transactions, essentially using blockchain as a distributed ledger for financial operations. Key innovations: decentralized currency eliminates the need for central banks. Proof of work (POW) consensus introduces mining, block rewards, and difficulty adjustments. Public blockchain: anyone can read and participate in validating transactions. Limitations: limited to basic transaction records, no robust support for complex logic or automation, i.e., no smart contracts built into the protocol at this stage. Blockchain 2.0, the smart contract revolution. Overview: spearheaded by Ethereum, launched in 2015, introduces the concept of smart contracts, self-executing agreements with code stored on the blockchain. Key innovations: Turing-complete scripting allows developers to program a wide array of decentralized applications, dApps. Ether as a native token used to pay gas fees for running complex operations. Expanding use cases goes beyond mere financial transactions to include supply chain management, gaming, voting systems, etc. Impact: paved the way for initial coin offerings, ICOs, and DeFi, decentralized finance platforms, gave rise to larger developer communities exploring innovative solutions. Blockchain 3.0, scalability, interoperability, and advanced use cases. Overview: this stage focuses on addressing the challenges found in earlier versions, primarily scalability, handling more transactions faster, and interoperability, communication across multiple blockchains. Key innovations: Layer 2 solutions, e.g. Lightning Network for Bitcoin, state channels, sidechains, rollups for Ethereum to handle greater transactions throughout. Interoperability protocols, e.g. Polkadot, Cosmos, that let different blockchains exchange data. Better governance models and upgrades that can be enacted without contentious forks. Impact: opens the door for enterprise-grade adoption. High-speed transactions and more seamless user experiences, encourages cross-chain applications and asset transfers. Blockchain 4.0, enterprise integration and industry-specific solutions. Overview: emphasizes user-friendly interfaces, advanced development tools, and robust enterprise solutions. Focuses on real-world, large-scale adoption, e.g. supply chain, healthcare, finance. Key innovations: private and consortium blockchains for regulated industries and business-to-business use cases. Smart contract frameworks that can handle complex corporate requirements, identity management, data privacy, compliance. Integration with emerging technologies like AI, LOT, and big data. Impact: encourages widespread adoption by corporations and government agencies. Enhances performance, security, and regulatory compliance for mission-critical applications. Note: some discussions even mention Blockchain 5.0, focusing on AI-driven consensus, quantum-resistant cryptography, and deeper synergy with LOT. However, the most commonly cited versions are 1.0 through 4.0. 2.2, types of blockchain. Beyond these versions, blockchains also vary in architecture and accessibility, shaping how they are governed, maintained, and utilized. Let's explore the primary types. Public blockchain. Definition: a fully open network where anyone can join, validate transactions, or create new blocks. All transaction data is publicly accessible. Key features: permissionless, no gatekeepers. Anyone can connect to the network. High transparency. All records are publicly verifiable, promoting trust. Community-driven consensus. Participants collectively secure the network, e.g. proof of work or proof of stake. Use cases: cryptocurrencies, Bitcoin, Ethereum, decentralized finance, DeFi, open lending platforms, asset exchanges, Global DApps, available to anyone with internet access. Pros and cons. Pros, high transparency, censorship resistance, strong community governance. Cons, generally slower transaction speeds, potentially high energy consumption in POW systems, less privacy. Next type, private blockchain. Definition, a blockchain restricted to specific members or organizations. Access rights are tightly controlled and only authorized nodes can join and validate blocks. Key features, permissioned. The network owner designates who can write, read data. Faster consensus. With fewer participants, transactions can be confirmed quickly. Centralized governance. A single entity or small group typically manages the network. Use cases, enterprise solutions, internal data management, automated record keeping, financial institutions, faster settlement times, and regulatory compliance within closed networks. Pros and cons. Pros, greater privacy, higher throughput, more control over data access. Cons, less decentralized, possible single points of failure, reliance on trusted entities. Hybrid blockchain. Definition, a blend of both public and private blockchain elements, enabling selective transparency and controlled participation. How it works, certain data or transactions remain public, visible to anyone on the network, like in public blockchain. Other sensitive operations or records stay private, accessible only to authorized parties. Key feature, configurable privacy. Decide which aspects are open versus restricted. Selective participation. Some nodes can be public while others remain private. Adaptive consensus may allow both public consensus mechanisms like POW alongside private validation processes. Use cases, supply chain management, publicly verified product authenticity while keeping sensitive business data private. Healthcare, patients own their medical records publicly for certain verifications, while hospitals keep personal data private. Pros and cons. Pros, balance between transparency and confidentiality, customizable to various regulatory and organizational needs. Cons, implementation complexity. Governance models can be more intricate. Next type, consortium blockchain. Definition, a special type of private or semi-private blockchain managed by a group of organizations rather than a single entity. Key features, shared governance. Multiple stakeholders collaboratively manage the network. Controlled membership, only pre-selected nodes. Usually organizations can participate. Efficient consensus, commonly uses BFT, Byzantine fault tolerance, or other consensus methods suitable for trusted parties. Use cases, banking and finance, interbank settlements, payment networks, e.g. R3 Corda, supply chain consortia, multiple companies within the same industry share data securely, e.g. Hyperledger Fabric for multiple enterprises. Pros and cons. Pros, faster than fully public blockchains, fosters collaboration among trusted participants, maintains partial decentralization. Cons, less open than public blockchains. Governance can be complicated as multiple organizations must agree on changes or upgrades. Key takeaways, evolving versions. Blockchain technology has advanced from facilitating simple cryptocurrency transactions to sophisticated decentralized applications. Each version addresses new challenges and expands the range of possible use cases. Diverse types. The choice between public, private, hybrid, or consortium blockchains depends on factors like data sensitivity, regulatory requirements, transaction speed, and governance needs. In conclusion, there is no one-size-fits-all solution. Each type of blockchain excels at certain tasks, so it's important to match the right architecture to the right application. For instance, a public blockchain is ideal for open, trust-minimized environments, while a private or consortium blockchain might suit regulated industries or business consortia that require private and faster throughput. The rich tapestry of blockchain versions and types underscores how adaptive this technology has become. Whether you're aiming to launch a public cryptocurrency network, build a private data shared solution for your enterprise, or create a hybrid system that does a little bit of both, blockchain has got you covered. End of lesson 2.